Hey gang, Chase here, and today I want to have a quick discussion about codecs, a very complex subject. We're not going to be getting into any specific codecs today. Our goal will be to give you a basic understanding of how they work so you can assess them on your own. Let's get started. When you think about it, capturing, working with, and playing back digital video is asking quite a lot from any piece of technology. Shooting the most basic video footage requires a camera's sensor to capture the light available, then turn that light into the highest quality digital information that it can, and save as much of that information as possible onto a storage device. And you'll eventually need a computer or TV to reanalyze, reassemble, and play that information back at its highest quality possible, sometimes while it's streaming over the internet. Codecs are what make all of this possible. A codec, which is a combination of the words compressor and decompressor, will compress the information of a video and audio signal into a more manageable file size or type when being saved, then help decompress that file the best way possible for viewing, transferring, saving, etc. Within a single project, you're likely to end up using several different codecs at different stages, the first of which is your capture codec. If your final video is just scratch, or you have a limited amount of storage space, you're going to want to have a codec that's a little more compressed. It's going to be a little bit lower quality, but generally speaking, when you're recording, you're going to want the least compressed codec that will save the most data and give you the highest quality image possible to work with. Codecs utilize many different methods of compression during every step of the process. Right now, we're going to focus on two key things that are very important for the record codec. The first is bit depth. Each pixel in your video has a value assigned to its red, green, and blue channels that will dictate how each of those colors mixes together to recreate the color that the camera sees. Bit depth determines the amount of different colors that your camera's codec has the ability to recognize and record. For example, cameras utilizing a 12-bit codec means that each RGB channel will utilize 12 bits for a total of 36. What this translates to is that it's going to end up having 4,096 different colors available to choose from to recreate your image. Now, saving so many different colors is going to require a considerable amount more of extra storage space on your media. 8-bit codecs are very common. Each RGB channel uses 8 bits of data, which translates to about 256 different possible color values per channel. You can still get great looking images from 8-bit. It's just going to take a little more effort. Smaller bit depths result in a degradation of the image and an increase in banding because there are fewer colors available to shift between. Another way your record codec will compress an image is through chroma subsampling. 444 chroma sampling is the best option you can have. This means that in a group of 4 pixels, each pixel's individual color will be saved. No color information is lost, so the image quality is better at the cost of more information, taking up more space on your media. But some codecs subsample color. A 422 subsample rate means that in a group of 4 pixels, 2 of them will disregard their own color and take the color of the pixel they are next to in an effort to lose information and save space on your media. Another common subsample rate is 420. In the same group of 4 pixels, 3 will disregard their color and take on the color of the remaining 1, but it will save a lot of space for you in the end. Now that we know a little bit about capture codecs and how they decide what information to keep or dispose of, let's move on to edit codecs. Now you're ready to begin your edit. Here's where another form of compression that codecs use can really affect your edit process, and that's the difference between intra-frame compression and inter-frame compression. Intra-frame compression, also known as spatial compression, gets its name because all compression is done within one single frame at a time. It does this by separating the individual frame into different sections, analyzing those sections for similarities that it can compress down, then saving the frame. Inter-frame compression, also known as temporal compression, gets its name from calculating the current frame, then only saving the difference in each frame after that. Because intra-frame compression is self-contained to each frame, your computer is only going to have to recall that single frame to play it back for you as you move around and manipulate your timeline. This is typically a better looking compression style anyways. But viewing frames of an inter-frame compressed video file means that the computer must not only find and display that frame's saved information, but it's going to have to go back through every frame before it to find the remaining saved information until the entire frame is built. And that's going to slow down your computer considerably. Sometimes, video files can be so big that whether intra or inter-frame compressed, a computer is still going to have trouble displaying all the information it has to in a timely fashion. A technique around this is to use a codec to compress the original captured footage into additional, smaller, more manageable files that we call proxies. Because they are smaller and lower quality, proxy files are easier to move around and manipulate, and when you have a picture lock, simply reconnect the original high-quality files for further correction or exporting your deliverable. Now your edit is finished and you're ready to create your final deliverable. The name of the game is to export the highest quality video possible without compromising its ability to play back smoothly. The codec you choose will inherently affect this outcome, but softwares like Final Cut Pro and Compressor, or Adobe Premiere and Media Encoder give you a few options to help you fine-tune a codec settings to best fit your needs. One thing you'll have choice over is your average bitrate. This is the average amount of information per second that your codec will be allowed to use. The higher your average bitrate, the higher the quality and larger the size of your final video. As long as you have a media player and monitoring device capable of playing back that much information a second, a higher bitrate is your best option. But you will likely be putting this video onto the internet, and larger files are more difficult to stream and play back. So you're going to want to lower that bitrate until you find the best quality image possible that's still easily playable through streaming. Here's a tip. If you're uploading to video hosting websites like YouTube and Vimeo, you should compress with a higher bitrate because they recompress every video you upload there anyway to make it more manageable and space efficient for them. In both Final Cut and Premiere-based softwares, you have the option of a single-pass or multi-pass export. In a single-pass export, your software will make a single pass over the video and compress it to the best of its ability, sticking close to the selected average bitrate throughout. A multi-pass export, however, goes through the entire video file once, assesses it for spots it can effectively allocate more bits for better quality when needed, or more compression when it's able. Then, taking that into consideration, it goes back to the beginning and starts building the actual file. This means you're going to have a better looking image when you need it and more saved space when you need it. Lastly, the keyframe or keyframe distance option will be enabled for any interframe compression exporting. We discussed earlier that interframe is not ideal for editing, but it's fantastic for compressing a video for playback. The amount you set here determines how many frames you allow your video to interframe compress before scratching the original template and starting all over again. Well, we hope you learned something from this basic rundown of codecs. As I mentioned before, this is a highly complex subject matter, and it was our hope that now you have a basic understanding that's going to help you approach and research them a little easier. For more tips and tutorials, be sure to subscribe to the B&H YouTube channel. Thank you very much.